So, hello and welcome to the next part of this tutorial. Today I would like to explain how to implement a height map into the terrain generator. And yeah, what we did the last time was combining this DirectX frame or this DirectX panel with some Windows forms, so we could actually change some settings in a menu. And we already prepared this menu load height map and reset, and this is what I would like to program today. So let's get straight into the code. The first thing what we will need is a height map. A height map is nothing else but a bitmap. I showed you one. This is already a height map. It's simply a bitmap made out of 64 times 64 pixels, and if I scroll in, it's simply somewhere in a very grayscale between white and black. And yeah, so it's a very small picture. In this case, it's 64 times 64. Whatever size we take, it would work. Also with a bigger one. This one I created, I think, years ago in Milkshape program, but there are several programs out there how to create a height map. And in the end, I would like to have my program able to simply load the height map or start from the scratch and just change the height itself and later save this whole thing in another height map, or simply creating your own height map simply by raising the terrain up and down yeah, dynamically during the runtime. And yeah, but for the first, let's see how it works to kind of load such a height map into our program. This is a 64 times 64 bitmap which we are using. So let's set the terrain for that, and we need here bitmap, and we call it heightmap, and this is 0. This is null heightmap. So how do we load the height map? Simply at our generate vertex, we created this double for loop with our set and our x coordinates, step by step, giving our x and our set position for each vertex, plus our color for each vertex. And the y coordinate is constantly set to 0. That's why we got such a plain terrain. So to load in such a height map, we simply copy this generate vertex, because we simply would like to have, once we load the program, to be simply a plain terrain. And after here, indices, generate indices, I copy and paste this in, and I simply rename this into load height map. So this is a new method, and a couple of things can stay the same, but we still have to add some. So the first thing I would like to use is an open file dialog, so we can choose what height map we actually would like to use. Therefore, I'm using this using statement. I learned that this is simply so that the open file dialog disposes properly, and we don't have to dispose it on ourselves, and it's apparently the way to go. Open file dialog, and I call it OFD equals new open file dialog. That's it. And now inside the using statement, we are just gonna give it a couple of settings. OFD title equals load heightmap. Then a bit more important, the filter equals bitmap files and star.bmp, and where is it? We simply want to allow just these bmp files, so that statements should filter all the folder into simply showing us bitmap files only. And now let's open the file dialog ofd dot show dialog. Here we are opening it into our form, and once we press dialog result OK, then let's do the following. And inside here we're simply gonna copy this, but first let's create actually our heightmap. Heightmap is a new bitmap, and one of the things is simply we type in the file name, and the file name is simply what we got out of our dialog ofd dot file name. Where is it? File name. And so now a bitmap should be saved into the heightmap variable. And then we need another thing, color. We call it pixel color, and let's leave it like this over here. And inside this pixel color I'm gonna save every single pixel step by step from this heightmap. So I'm gonna read this heightmap, and the heightmap is simply a grayscale, and I get the color information from each pixel into this color variable. And then I'm using simply this color value, which is somewhere between 0 and 255. I'm using this simply to put onto my y variable to give a height information to my terrain. So now we actually can copy this. I'm gonna put it up here. So okay, now inside here I now need to step by step, whenever I wanna set the height, I'm gonna set the pixel color first, and the pixel color equals heightmap dot get pixel. There is such a thing. It's down here. Get pixel from x and z. That's my two coordinates. And now it step by step goes through the whole heightmap and gives in each step of the loop the color of it. Why am I not putting this whole stuff instantly in there? I'm gonna show you soon, but first let's change this 0 into a dynamic pixel color. Pixel color dot and due to the fact that it's a grayscale picture, black, gray, and white, all these kind of colors are having simply blue, green, and red having the same value on. If for instance the blue part, the green, and the red part are all 10, then this will be somehow a very dark gray color. If everything is 100, then it's a bit brighter gray color. So practically in each of these blue, green, or red values, it's the same value set. So it doesn't matter which one we take. I just take the blue one, and we are having already our integer getting out of that, or actually a byte. Sorry, it's a byte. 0 to 255. We're getting a byte out of this, and that's it. And the point is, yeah, should this work now already? It should. Let's simply copy this, and where do we open it? Of course, inside the load heightmap. So where are we? Where is the double-clicked it? Here it is. Load heightmap. Once I click on the strip menu, it should do that. Calling this function, and we need to put all these vertices which we created there into our vertex buffer, and that's simply vertex buffer dot set data, and of course our verts 0 and log flags. It's the usual thing which we did this couple of times, and simply as soon as the vertex buffer has its new data, whenever it's being repainted, it's using simply the new data. Log flags dot none. So let's see if it's working. Menu load heightmap here, and something is not going properly. Let's see what it is. Pixel color dot b. Yep, and the reason why it loaded properly, but every single pixel, due to the fact that we have actually no black over here, so just some slight gray, it's a pretty high value already. It's somewhere most probably at 100, and if we load that stuff, I think we would have to look upwards. Okay, I can't see it, I can't find it. It's simply way too big scaled, so let's just divide this by 15 and even a -10. So -10, I do whatever is black or very dark. It would be even below 0. Oh. Okay, let's see, load heightmap. Now it is much smaller, and what you can see, it's very steppy. There are such steps, and this is simply because I actually didn't cast this into a float. It's simply a byte, or almost like an integer, and although the values would be saved properly, I of course have to cast this into a float first. And here we go. Heightmap. Very beautifully said. So there's one more thing. If I, for instance, make my terrain smaller, back to, let's say, go 30 and 20 or whatever. My terrain is smaller and I load that stuff, it will work. It would not show me any error, it would just load in that part of it. But my whole terrain is my heightmap is only 64, and let's now create a bigger terrain. Then of course there will be an error as soon as I load the heightmap, and the error is of course at get pixel. At one point it can't get that pixel anymore, and because we would like to have a pixel at 65 or 66, and it simply does not exist in our heightmap. So therefore we have to add here an if statement and check the heightmap dot size and dot width. If the heightmap's width is bigger than j, no, not j, we had x, and our heightmap size dot height is bigger than set, only then do the following. Yep. And now let's copy these these 3 lines up here. The k will leave outside, And otherwise, I would like to copy now these two in here. Otherwise, I'll leave the position at 0. And yup, that's it. So now it should work that we'll have a bigger terrain, much bigger terrain, and we load in a Heightmap which is much smaller, and yo, it seems to work. It loads in this part and the rest stays small, so we can partially load in a Heightmap. Later we can load in one Heightmap over here, another one over there, and so on, whatever we want, and however we want to extend this program. So one more problem is over here. As soon as I click on the fill mode solid, I don't see anything of the terrain. I see it a little bit over here, but if I go into it, I don't see any hills. It's plain white, and I don't see any shape. First of all, I change it back to 64. Simply, I wanted to show and prove that now we solved this. The point is, we have no lighting on yet. We did not define any lighting, and it's a little bit more complicated to turn on the light over here, simply because we have no normal vectors calculated yet for our vertices, and therefore, yeah, it simply would not work to turn on the lighting, because there are no normal vectors. The lighting cannot be calculated. But at the moment, before we do so, there's a little trick. We simply color the terrain differently, and we color it according to our pixel color, according to our Heightmap. So we use actually the color of this Heightmap to color our vertices. So yeah, this is a little trick to avoid the lighting and the normal vector calculation for now. So simply pixel color, here it is, .2 ARGB, and that should do the trick. Manual load Heightmap, here we go, let's fill mode solid, and here we go. We see a little bit of a grayscale. It almost looks like it's a shadow in the valley, but actually it's just colored. So in all the valleys, we have now grayer. Let's load in the other Heightmap. This one is a Heightmap. It's a bit more edgy, a bit darker. It's actually the Wikipedia Heightmap. So if you Google for Heightmap on Wikipedia, you can find this Heightmap. This one is a bit of a bigger one, I think 256. 256. And even if it's not that big, it shouldn't show us a fill mode solid load Heightmap. So yeah, and here we see already we are at the end of our rendering, and let's change this quickly as well. I would like to look a little bit further than just the 100 which we set in the beginning, and therefore here our projection matrix, our camera so to say, is only able to look until 100. Let's increase this to 1000, and now we should be able to easily load that Wikipedia terrain, Wikipedia Heightmap, and look at the whole one. Yeah, here we go. There's a big Heightmap, a bit too dark for my taste, but for an example I just wanted to show you. This is the Wikipedia Heightmap. Simply download it, put into the folder, and yo. So what else? Yeah, here I would like to additionally add one more line. The initial directory, and due to the fact that I used this already in advance. It showed me actually the right one, but for the future, application dot start path or startup path. There we go. So as soon as our thing loads, it checks our application path and starts the browsing over there. And yeah, one more thing is missing. It's this reset button. This one. Let's program it. So where is it? It's not here. I don't know why. Where's the reset? Hidden, scroll menu strip, solid, wireframe, background color, load. Ah, here it is. So to reset the whole thing again, we simply have to copy this, and we have to call, instead of load, Heightmap, the initial generate vertex method. With that, we created the initial, or the basic terrain with the y value at 0, generate vertex, and we simply call this again. And now we can load our Heightmap. Here we go. Oh, there's somewhere in the middle, it's a bit far off. And if we reset this whole thing, it's gone. I'm loading it again. Yeah, and this was a short and quick tutorial of how to use a Heightmap, how to load it, how to use the Y information out of a grayscale picture to put this into a terrain. And yeah, thank you very much for watching, and see you guys next time.